Okay, now what we're going to do is apply some of the log rules. So for example, this one, use the rule of sum and difference, log sum and difference, either expand it or simplify into one log. Okay, so let's take a look at this one. Log of 8x y to the fourth. So kind of recall that anytime inside a log function, if things are multiplied together, then you can split them apart by using adding. So you can think of it as this is basically 8 times x times y to the fourth. So we can split that into 3 different logs added together. So this is log 8 plus log x plus log y to the fourth. Now the question is, can we expand it some more? Yes, well, you kind of have to see different things. So for example, 8. 8 is really the same as saying 2 to the third. So then I could do some other stuff with that. So one of the log rules says you can take exponents and then put them as the front of the log. So log 2 to the third is the same as 3 log 2. And then this one is 4 log y. Any more than this expansion would just kind of be too many. For example, you could basically do this as log 2 plus log 2 plus log 2, but I think that's just a little too much of expansion. That's very unnecessary. So if you get to this point, I would say that's good enough and you can call it done. All right, let's look at another one. This one has a little bit of more extension that kind of requires that you remember what square roots do. All right, so first, natural log. Okay, let's kind of talk about this. This is natural log with ln. This is not in. This is not in and out. So please be careful. Don't write I. It is not I. It is L. Okay, so this square root is going over the whole x squared plus 5, so that is to the 1/2, like that. Okay, let's talk about expansion. We really have two things divided by each other, this one and this one. So remember, when things are divided, you would turn it into a log of something minus log something. So this is log of x squared plus 5 to the 1/2 minus log x, or natural log, sorry. This can come into the front again, so that's 1/2 natural log x squared plus 5 minus natural log x. Can we do anything else? No. A lot of people make this mistake of distributing. You cannot distribute a function. So, function means it's like x squared or 1 over x or sine. Those things are functions. You can't distribute a function to something else. So please be careful and leave it like this. This is it. All right, let's look at this one. This one we're going to compress or simplify into one natural log function. First, we have this coefficient. If you have a coefficient in front of a log, you cannot combine the two logs together. You have to get rid of that coefficient first. So this becomes an exponent. But an exponent for what? So this is another confusion that happens. So we know that 2 becomes an exponent, a square. The question is square for what? So a lot of people just kind of write it like this. That is incorrect. It is the square for everything inside. So be careful of that. So this becomes natural log x to the 5th minus natural log of xy squared, which is x squared y squared. All right. Now we're combining the two logs together. There's a minus sign in between, so that means we're going to divide them like so, and then just simplify it a little bit more. So x to the 3rd over y squared. Done. All right. Okay, So now let's look at this one. Evaluate, excuse me, log base 4 of 7. Log base 4 of 7. So when the base is not a normal base, so what's a normal base? Log base 10, which is log, or log base e, which is natural log. When there is no such base around, if you don't have a calculator that can evaluate different bases, then you're going to have to do something where you change it to one of these two bases. Fortunately, TI calculators or TI-84 and higher does let you change the base, so you can try to find that. But you still need to know how to change the base just in case you get to a problem where you cannot. How do you change base? Well, depending on what base you want to change to. So let's say you want to change both this to a log base 10, which is the log. Then you can just say this is log of, so log of what? Oh, sorry. Erase that. Okay, log of what? It's going to be log of 7 over log of 4. So it's always the log of whatever is inside over log of the base. Okay, same thing. If you want to change it so that it is a log base e, which is natural log, you can say natural log 7 over natural log 4. Anything you do, as long as it's the same base, you can also do log base 4 if you want. You will keep getting the same number, so it really doesn't matter. And there's a proof for that, but we don't have time to go into that. So this is kind of the big idea. If you have log base b of x, you can change it so that they have the same base. So I just kind of randomly wrote a base a for both, and then you would just say, this x goes there, b goes there. All right, let's practice using only natural logs and then evaluate. Okay, so for example, this one, you would say, oh, this is natural log 8 over natural log 3, and then use the calculator, and the calculator says 1.893. So go ahead and use the calculator for this one, figure out what this number is. This number is 0.565. All right, now let's practice. So it says to rewrite this expression using only common logs. What is common log? Common log is log base 10. So they want you to write this with just log base 10. So let me kind of show you how to do that. So for example, this one would be log x over log 2. Very easy, just change the base to a 10. Okay, let's have you try this one. This one's a little bit trickier, so go ahead and do it, and then I'm going to show you one more step after that. So you probably would get log of x plus y over log of 1/2. Okay, just another reminder, please do not distribute. This is not okay. Now, the extra step that we want to take is this part. So log of x plus y, there's nothing we can do with that. Log of 1/2, log of 1/2. Remember that if you have some kind of division problem inside a log, you can change it to a subtraction problem. Now recall, log 1 is really just 0. Any log of 1 is 0. So this is gone. So you only have log of x plus y over minus log 2. All right, now we're going to use this whole idea, but we're going to figure out some transformation. So we're going to skip this one and then just go straight here. It says determine the transformation from natural log x. Sketch the transform graph. Okay, so what it's saying is that what is the transformation of this problem if this problem were a natural log x? Well, that just means that we want this to have a natural logs inside. So we want to change this problem to a natural log x. So that requires a change of base. So natural log x over natural log 5. All right, now we have this here. The question is, what is this thing that is transforming this natural log x? Well, let's take a look. So, for example, I'm going to isolate this natural log x, which means in the front, I really have this coefficient, right? So you see this 1 over natural log 5, and then maybe you just immediately want to say, oh, that's a compress, or that's a vertical compress. But you need to verify. So you're going to put that in your calculator, 1 over natural log 5, and figure out what that number is. 1 over natural log 5. Not just natural log 5, but 1 over natural log 5. This turns out to be 0.621. So this number here is 0.621. And then what is 0.621? Well, that number is between 0 and 1. So this is a vertical compress. By a factor of what? By 1 over natural log 5. Okay, so kind of let's review that. Whatever the log they want you to transform, they want you to figure out the transformation from, you want to change this log into that log by change of base. And then look at what's being attached to it to figure out the transformation. So for example, this one, log base 1/4, log base 1/4. So let's have you try this. You're going to figure out what it would be if it's in natural log x and then figure out the transformation. All right, you should get natural log x over natural log 1/4. Now remember 1/4 is 1 divided by 4. So that means you have natural log 1 minus natural log 4. This being 0, you have natural log x over minus natural log 4. Okay, again, take that, put it in the front. Now put 1 over natural log 4 in your calculator. Again, that turns out to be a number between 0 and 1. And we have an extra transformation, which is this reflect over x-axis. And then we have vertical compress 1 over natural log 4. All right, this one is very similar, so we're going to skip number 3. Now let's talk about analysis again. Identify the transformation and perform full analysis for this. This is a little bit confusing. So transformation from what? So from y equals natural log x. So if this function is a natural log x instead of log base 1/3, then what would be the transformation? And what is the analysis of this problem? All right, let me kind of help you with the transformation first. This one is a little bit tricky. So first, let's change it. So natural log 9x over natural log 1/3. So notice how we're definitely not done. We're trying to figure out the transformation from natural log x. There are many ways to describe the same thing. If you leave this 9 in here, then you know that you're going to have a horizontal stretch or compress. If you decided not to leave that 9 in there and then you said, oh, you know what, I'm going to make it so that it's like this, then you're going to have a up or down. You have a vertical movement. So this one gets quite crazy depending on, how you want to simplify it. Well, let's do this. I am going to do a lot of things to this and in hopes of maybe simplifying it more. I don't know. Okay, we get to this point. I'm going to put the 2 in the front like that. That's an X. This is 0. I'm going to split this into 2 fractions. I'm doing a little more kind of simplification on the way. Maybe I will do it a little bit slower just in case. So 2 natural log 3 over minus natural log 3 plus natural log x over minus natural log 3. All right, this cancels minus 2. And then minus, I know that's going to be a coefficient of natural log x, like that. All right, now we can kind of talk about transformation a little bit. So we got this minus 2, so we know we definitely have a down 2 there. We have a negative, so on the outside, so that's reflect x-axis. And then we have a 1 over natural log 3, and so you got to put that in the calculator to figure out if it's compressed or stretched. That turns out to be a number between 0 and 1, so this is vertical compress. 1 over natural log 3. Sorry, this is quite messy. So that would be the correct function. Now you need to put this in the calculator to figure out how it looks like, so you can figure out the analysis. So which function should you put in? It really doesn't matter. It's the same function anyways. You can put this in there in a calculator if you know how to do the base change in your calculator, or you can put this in the calculator. It really doesn't matter. It's the same graph. So go ahead and pause the video, try this, and then come back and check your answer. Okay, so what you want to remember about the log graph is that without any transformation, any left and right, up and down transformation to it, it really is always going to look like this, where it has a vertical asymptote at x equals 0. And it just pretty much always looks like this. Now, with all this transformation going on, this graph actually ends up. So this is actually how the graph looks like. Remember, the graph keeps going, even if your graphing calculator shows it stops, but it's not true. So let's look at the first domain. All right, so the domain is going to be greater than 0. There's an asymptote, so it's not equal to 0. So you can either say 0 to infinity, or you can say greater than 0. The range, I know it doesn't look like it, but it's actually all real numbers. You kind of have to memorize that. It is always all real numbers. Continuity, so you can say it's continuous on the amount of domain that it has. This one has no increasing interval. In fact, it is always decreasing, but you want to say 0 to infinity. Asymptote, it does have one asymptote at x equals 0. And so let's talk about end behavior. End behavior, x goes to infinity, then this function is going down, so negative infinity. This one, you wouldn't say that x is going to negative infinity because there is no negative infinity. X can only really go to 0, and then it's going to stop there, and then the graph goes up.